welcome to another great episode of IT Pro TV. I'm your host, Daniel Lowry, and in today's episode, that's right, we're moving forward with our VCA 6 series. Joining us back in the studio again today to help lend his expertise on that very topic is our good friend, Mr. Ronnie Wong. Ronnie, welcome back to the show, sir. How's it going?
Well, thank you for having me back as we continue on taking a look at our VCA 6 series here. What we're actually taking a look at today, of course, is going to be networking technology that we tend to find inside of vSphere 6 as well. Now, in terms of networking, okay, this is where the data center virtualization also may actually extend a little bit beyond those of us that have actually just only done the idea of server virtualization or, of course, desktop virtualization. In other words, just bringing up one on our hosted hypervisor too. So when we take a look at it, we've actually done a little bit of it, right? And we've had any experience with virtualization at all, okay? More than likely, what has had to happen is once you created your particular VM, you needed to connect it to the outside world, and the nice thing is most of the hosted ones by default automatically connect it for you, okay? So you bring it on, you turn it on, you actually know something right away. It gives you an IP address, which you go, I don't know where the heck it got the IP address from, but then you actually open up a browser and you can connect out to the internet. Well, that's what we call virtual networking, okay? The very fact is, what is it doing, okay? Inside of that particular VM, right, it actually includes in virtualized hardware, and one of those pieces of hardware is going to be, of course, the NIC itself, is what it virtualizes, and then it also, of course, has to connect out to the world to do all the other things it needs to. And because if you actually take a look at it a little bit more, you actually end up seeing that it's also doing NATing, so it actually may include a router as well as a switch and everything else. And you're like, are you joking me? No, inside of that particular little VM itself, it has everything built into it. So that's what we're talking about today too. Now when we get into the data center level of things, right, we're actually moving beyond that one and saying that we can actually do this where we can actually manage all of those virtual machines, because each one will actually end up having a NIC itself, and also of course we'll have what we call virtual switches, and we may even have other virtual types of storage appliances that are not storage, excuse me, security appliances, router appliances, you name it, they're all out there that can help us to do all the things that we actually need to do in terms of networking, okay? So remember that when we compare and contrast them, right, in a physical instance here, every machine that you tend to have, of course, in terms of networking, will have at least one NIC, okay? And the nice thing is, you can add in more. After a while, you actually run out of space, and the same thing will also happen on a virtual machine too, is that you can add in just so many virtual NICs, and each one of those then you can actually attach to, well, another appliance, okay? You can actually attach that to a virtual switch. Well, in the physical world, that's what normally also happens too. You take a NIC, you add a cable into it, and you attach it to a switch, and then you're off and ready to go at the other end, okay? So there are actually nice parallels between the virtual world and, of course, the actual physical world in terms of the components that you need in networking.
So, Ronnie, we're going to be able to take our basic networking knowledge and just apply that to the virtual world that we have with VMware and not have to really learn. No, you don't have to relearn basic networking is what you're saying. What we do need to learn is VMware and how VMware actually handles things like switching and routing and NATing and all that. So I guess a good way to go is, where should we start with that?
Yeah, when we start taking a look then, right, you want to make sure that you understand that there are actually some different technologies that are actually built into vSphere that's going to help us out. But it really does begin with at least the concept, just like what Daniel was talking about, is understand that every single VM that's going to be networked at some point has to, of course, connect to a virtual NIC itself, okay? So that NIC usually is going to be kind of a software version of the physical NIC that you have in that host. Now, it doesn't always have to be, but usually it is. In most hosted software environments, like VMware Workstation or VMware Fusion, like what I'm running, it does. It essentially takes your NIC, okay, and it makes a virtual copy of it, and then that way it actually thinks it's actually really has its own NIC of that same variety and flavor. Inside of vSphere, though, you can actually just connect it to, well, what we call, whatever that is, whatever NIC that is, you can actually connect it to one that actually aggregates all of the actual network capacity together and give it much more access to more networking capability than you had. In other words, bandwidth than you actually had at the beginning. So when it comes down to it, what are we actually doing in terms of the devices here? Well, let's go ahead and show you how this actually integrates into VMware, and we'll actually show you some of the components too. So when we start talking about virtual networking inside of vSphere, okay, so here's our standard web client, and usually it defaults to this, this view right here. So I'm at the home screen where you actually see everything, not the home screen, but the actual view here on hosted clusters. But notice up here at this top bar, I'm going to go over to this little icon here that says networking. And when I do so, I'm going to click and change our view just a little bit. And you'll see the icons change over here in this navigation area as well. And then here's what it breaks down to. I'm going to make sure I click on that very first tab here. Okay. So when it comes down to some of the different things in virtual networking, we have what we call virtual standard switches. The older acronym for it is, of course, lowercase v and then SS, right, for standard switch. But in today's documentation, you don't see that kind of written out that way too much anymore. So this is kind of the first beginning here of a software representation of what they put inside of ESX. Okay. Now this actually means that there is a virtual switch running when you actually have ESX, and every single virtual machine that you create inside of ESX, I'm not going to be able to say that. Every single one that you create ends up attaching itself to what we call this virtual standard switch here. Okay. So every single virtual machine by default actually gives you that ability to connect into at least one network. Okay. Now, do you have to connect it? No. Inside of VMware, vSphere and VMware's VMs, that's really going to be confusing. Never mind. Inside of every single virtual machine, you actually have the ability to create from 1 to, I think, 4 actual virtual NICs. Okay. Actually, I'm telling you, like 0 to 4. I said 1, but it's 0. So you can actually have none. Okay. That's the lowest number of NICs that you can have. And then I think you can have a maximum of 4. So every VM can actually attach between 1 to 4 network connections if you want to. And usually when you do so, they attach into what we call this virtual standard switch here. Okay? That will give them access to other VMs, okay, that are actually represented in something that we call their own port group. Okay? It will also give them access to the physical world that's also out there in the world as well. So when you do select this, and you actually can create these, it says a network standard, let me zoom in, that'll make it a little bit easier. A network with a standard switch is a network of virtual machines running on a single physical machine. So if you're only talking about one ESX host, I know that's going to kill me. That's what you're talking about, you're dealing with in terms of virtual networking, is one standard switch, okay, is what's going to happen here. And so you can actually see where they can send data to each other as well as actually connect out to the world. And this is kind of the weird thing for me at the beginning, because I didn't understand how this worked here when I first started with virtualization, is that I can have 3 or 4 virtual machines, but they're really only connecting out through one physical NIC. Okay? And that's because of the way it virtualizes it, and that NIC can handle the traffic between them. So this is the same thing, is what you're seeing is essentially a software representation of the NIC that you tend to have on that particular machine there. Okay? Now the advantage of this type of NIC, though, is that even though on most like desktops here, right, you're going to see that there's going to come a point when you can actually do too much to that NIC. Okay, so in other words, you can send so much traffic to it where it actually doesn't perform well anymore. In theory, on the standard switch, you can have up to 120 devices connected to that one. So even though it actually allows you to have up to 2,048 machines, essentially only 120 of them are really actually kind of connecting to each other at any one millisecond or microsecond, whatever you want to call it, at a time. So there is a limitation to the number of what they call logical ports that you have in that too. Okay, so they can actually talk between each other, and you have that 120 port instance there that you have to worry about. Now the other thing, of course, is if you have multiple NICs, then well, every single NIC that you have on that host can be aggregated together. So that way, if they're, let's say, for example, if they're each gigabit network adapters, right? If you have 4 of them on the physical host, that means you can actually give up to 4 gig connections, across for just about every machine that's going to be virtualized on there as well. So you can actually share that bandwidth across them too. Now, the only other thing that you have to worry about, right, is that there's also, of course, to that virtual switch, it has to connect to the physical switch. So you actually have to take up one of those 120 port connections that you'd make to a VM. So technically, even though they tell you 120 VMs, one of those ports is actually going to be a connection to the physical NIC itself, and that's what they call a DV uplink instead, if I remember correctly. Yeah, I think it's called a DV uplink. So when you start taking a look at that, there are some things that actually allow you to do this. Now, you might be wondering, why the heck is this important? Well, if you're going to connect into VMware, for VMware to be able to manage ESX host right through software, it can't manage the physical NICs on every single host. So this standard switch here, this virtual machine switch, essentially is kind of the connection point, right? So that your ESX host can now also have its networking begin to be managed by vSphere. So that's really kind of the first thing here that you end up doing. Now, when you start taking a look at switches, right, standard switches as well as physical switches, there's only one, I only have one drawing that I'm showing you, and I hope this makes a little bit more sense. Remember that the operations that happen on a switch really happen in what we call two different planes here, okay? If you're talking about configuration on switches, there is, of course, another layer of software, if you want to call it, that it's only about configuration. So when you actually configure a port or a VLAN and stuff, you're doing that in what's called the management plane, okay? Everything else on the switch, as far as data goes, port forwarding, filtering, tagging, VLAN tagging, you name it, all that other stuff happens on what we call the data plane, okay? In a standard switch, this happens one ESX machine at a time. So that means if you're going to be configuring it through vSphere, the standard switch, you still have to select that particular ESX host, go to the standard switch and configure it. Same thing again, standard switch and configure it, okay, on each one. But there is also what is called a distributed switch as well. Let me see if I can get to it here. Oh, let's see. At least I think there is. Getting started, that will actually help out. There's also what is called a distributed switch. A distributed switch says, all right, vSphere actually sees multiple ESX hosts, and it wants to manage not only each one that's actually on the individual machines, but it wants to be able to manage all of the actual networking on each ESX host. And the way that you do that is by creating what you call this distributed switch instead. In the distributed switch, the management plane becomes centralized inside of vSphere, okay? But yet all the other data stuff is handled per machine, okay? So those are kind of the basics that you want to understand, right? So if you have configuration that needs to be done between 4 or 5 different ESX hosts, okay, well, you're going to actually probably do that on a distributed switch. If you're talking about the traffic and the aggregation of them, that's actually done by the actual individual machine. So in other words, you're going to actually do something like that on the standard switch, which I can't remember what to actually say there. So those are kind of the two big ones that you actually think about, okay? Another term that you want to be familiar with, especially with the standard switch, is that they talk about the idea of bridging traffic between VMs in the same port group, okay? That's done at the standard switch level as well. Now, what the heck does that mean? It means it connects one logical port to another logical port. Just like we have in a physical switch here, we actually connect one to the other, you actually will see that as well, okay? So here it is. We have what we call our standard switch, in which we would configure on each individual ESX host, and then a distributed switch instead. Notice it says it actually acts as a single virtual switch across associated hosts. This allows virtual machines to maintain consistent network configurations across the actual host that they're actually migrated to. And you have, of course, the ability to actually do more and more management on stuff like that. So it actually is kind of a neat concept and a technology that we really want to make sure that we pay attention to when we start taking a look there, okay? Now, the other thing about, of course, the distributed switch here, and we can actually take a look at some of the things that we would need to configure. So let me go back here instead of just jumbling on here. So I'm going to select the standard switch again, and I'm going to click on Manage. And you'll actually see that this is where you configure like the IP address is what you would actually do here, okay? So you'd actually select that. Oh, there we go. And so you can actually associate a network profile. Let me get out of this thing. I keep expanding out there. But this is where you'd actually see the associated profiles. Be able to also configure those too. So on each individual host, that's why you'd actually do something different. Inside of the distributed switch, if I now select the Manage here, This is where we can actually go in and select a lot more. So notice that there's a few different aspects here that you can actually take a look at. So one, of course, is something like the resource allocation. Here, I was about to say allegations. That wasn't actually going to work here. Where you actually create network resource pools where you can aggregate that traffic together. This is, of course, also where you can go in and add in your port IDs for your networks. Be able to also manage network protocols, add in permissions as well as VLAN tags, and even create alarm definitions for policies that you might have set in place. So there is a lot of different things essentially this allows you to be able to do. So that's why we actually use those. If we're using vSphere, we're going to either see standard switches or we're going to see distributed switches here. Distributed switches when you have more than one ESX host. Standard switches when you're really only dealing with the individual ESX hosts.
Yeah, that's very cool. And that lets you know that this is going to be able to let you have either a very simplistic environment, right? We have the standard switch for that very purpose. It's very simple. You don't have to worry about, oh, is there a configuration here, a configuration there? I've got to just turn your virtual machines on, they connect, and you're off to the races. But if you need a little more horsepower, you can go to the distributed switches, and they will definitely give you all that you need when it comes to that. Now, Ronnie, are there any other concepts when it comes to these virtual switches that we need to be aware of?
We really need to take a look at the idea here that it's not just about connecting them, right? The strange thing about networking, right, is that it really does seem that simple, is that you connect the devices and they just start working and they start doing that. Well, now when you start having multiple switches and multiple network types of connections, you start realizing that you can do things like oversaturate the network, right, by sending too much traffic. So we might implement something like we call the idea of QoS, right, quality of service stuff, on a regular network to make sure that we actually give everybody enough room, okay? We also want to take a look at the idea of monitoring the traffic, verifying that we can do all these things that we need to do as well, and that we're not actually oversaturating one, but also maybe if a device goes down that we actually know about them too. So the nice thing is, a lot of times when we do stuff like that, we talk about the idea of implementing policies. The strange thing is, in a physical world, it's done by device is how you actually have to configure the most of that. But inside of vSphere, okay, in the virtual networking world, you instead can set policies, and because you also have created distributed switches, pushes those policies right out. Let's take a look at some of the most common networking policies that you'll generally find, okay? So when we take a look here then, okay, I'm going to be on the networking tab, and then what I want to do is I want to select one of these. So I'm going to select this management network here, okay? And this is what they call part of a distributed port group. We're not really getting into port groups too much here, okay? But you can see it says is a port group associated with a distributed switch that specifies port configuration options for each member port. Distributed port groups define how a connection is made through the distributed switch. In other words, it's just saying, here's how we logically group this together to actually implement policy. That's what it comes down to when we start taking a look at that. Okay? If I click on Manage, and then on Manage here, I'm going to select Settings, and notice that there is a whole option down here called Policies. And let me click Edit here. Okay? So the most common things that we can actually set on each distributed one, okay, happens to be some of these common policies. Now, general is a little bit different here, but when we start taking a look at policies, we normally take a look at the idea of security policies, right? We can tell whether or not we actually want this particular distributed switch here to actually be in promiscuous mode. We can actually change what happens when somebody actually does MAC address changes. We can reject them, and even forged transmits. Okay, so there's a lot of security here. What we were mentioning earlier are things like QoS policies. And notice you absolutely do have these. So here's one that shapes inbound traffic, okay, for traffic shaping as well. And traffic shaping is just ensuring that, hey, everybody actually is getting the bandwidth that they need. And of course, you can actually do it on both sides, whether actually inbound or outbound. Traffic shaping really does ensure and guarantee that everybody actually gets the traffic that they need and doesn't drop any packets, but it allows you to do that. And of course, VLANs. You want the traditional VLAN trunking if you're connecting multiple virtual switches together. VLANs, just regular VLANs, or private VLANs, allowing you that even within a VLAN to actually create another kind of private VLAN within that. All right, so there's also, of course, policies here on teaming and failover, and it's exactly like it sounds. The very fact is we can do load balancing across these NICs, and you see them right here where they show these uplinks. Uplinks really mean how we connect to that physical NIC itself, and you can see all 4 of these uplinks here. And so you can see where we can do load balancing, connection failures, notify, you name it. There's a ton of these. Now, those are by far some of the more common types of policies that we can set in networking, but I wanted to save this advanced one for last here, because you can actually see where you can override what we call port policies as well. Okay? So this gives you the ability to do all that stuff just by allowing it or disallowing it. Now, most of us, if we come from the networking world as far as physical networking, all the rest of the stuff you're like, okay, but I think I really don't want to do that. Well, you can actually just say whether or not you actually allow it or disable it if you actually wanted to instead. So this way you can actually turn it off, and that way nobody else gets access to it. You name it, there's actually still some different of these switch policies that you'll just need to actually understand that are available out there. Now, most of the time when we're talking about it for the exam, you're probably not going to get that much in depth into it, okay? But the reason why I say this, right, is because it's one of the exam objectives where it says you need to be able to identify the most common. So that security, the failover stuff that we actually showed you, the idea of actually creating those VLANs, those are kind of more common policies that we were taking a look at. Make sure you actually take a look at them again, because again, I'm not going to tell you that a lot, and traffic shaping I think is the other one. But those are kind of the ones that you need to make sure that you do understand, at least for the exam, as you continue to go on through there as well. Okay, so even though a lot of this doesn't tend to really apply much to us physically plugging in stuff, well, once you actually have those NICs up and running, every single VM you can essentially attach to those types of networks. So let me go back here, and now if I select like this Linux machine, and then I click on Manage, let's see if I can actually select this here, and then there it goes. So you can actually see right here, I didn't want to do too much. You can see the network adapter is actually attached to this, what they call VM network, and that is actually a virtual switch that they've created that says, look, here's one of the networks that you can actually attach to. So that way it actually can do everything that we need to without having to actually buy more and more additional switches. We actually can create them on our own, even if we go, man, I need to actually have another network. Well, usually I'd go, okay, Daniel, order me another Cisco switch, a 24-port switch, and we're off and ready to go. Instead, I can actually create that virtually as a virtual switch, a distributed switch, or even a standard switch here, usually a distributed one, and then everybody can connect to that, and we are off and ready to go as well. So it really does help to understand some of these basic technologies that you'll see in terms of virtual networking too. Now, we do have to talk about one more thing, okay, which is, of course, as there was a storage I/O control, right? So I don't want to massacre that acronym again. A storage I/O control, there's also a network I/O control as well, okay? Now, the network I/O control, okay, is about ensuring that one particular data flow doesn't get to saturate the entire network. That's what it comes down to, okay? Just like we talked about in terms of storage, where one device says, I need all the I/O that I need, everybody else can just wait until I'm done. Well, the same thing in terms of networking can go on too. So instead, network I/O control ensures that a given single data flow is not going to dominate every other traffic flow that's actually there. So what is it really doing? It's preventing, of course, network drops from happening, okay? And it's also preventing what we call jitter, right? That kind of uneven flow of the data, and then we getting some things and we're not getting other things too, okay? The other thing, the way that it actually works here as far as network I/O control is it uses what we call quality of service, okay, to ensure and to enforce, well, again, things that we want to, such as the idea of traffic isolation. If we need one particular traffic to go one way, okay, and we say, look, that traffic's only going to go here, but not onto the common network, we'll do something like that. And you might be wondering, why the heck would I use that? Well, that's what vMotion's about, right? The very fact is we want vMotion. We want the fault tolerance. We want the fault tolerance logging. We want all that to actually be on its own separate network. We don't want it flooding over our production network. So the ability to actually do the isolations like that as well. Also, it actually lends to predictability. If you can actually use network I/O control to do so, you can now predict when you're actually going to face very heavy traffic versus when you're not, okay? And that way you actually know where traffic's going, and you can actually start configuring your network for that. And then, of course, overall prioritization. Because you can now actually take a look and monitor that stuff, predictability and prioritization gives you that ability by using that QoS again to ensure that everybody gets what they need to. Okay? So it really can be incredibly helpful when you start doing this. So where in the world do we turn something like that on if we need it? Well, I'm going to go back to this networking icon. And from there, let me see here. I am going to then select on the site itself. Make sure I actually tell you right. And then inside of Manage and Settings, I'm going to click on Edit. And this is one of the things that really kind of is neat to me, right? So all you can do here is pretty much enable it and disable it. Well, what about all that other stuff that we were talking about, that you're saying you can control through this? Well, all that's done through the policies, okay? So it all fits together so that you can actually change it up and do what you need to through the policies. But what actually implements it is this network I/O control. And simply by saying enable or disable, you actually can use it the way that you want to. More than likely, network I/O control is probably something you're going to enable, even if you don't actually, I don't know if it's actually enabled by default. It may be. But it's something you're probably going to want to enable, especially if you run multiple VMs at the same time, and they're all production servers. You'll probably want to implement it.
All right, Ronnie. Well, obviously our VMware systems here are quite robust when it comes to their networking capabilities. And if you have a foundational knowledge of networking, you've ever worked with switches, you've ever worked with just the basic connectivity, then you're probably not going to be too far out in the weeds on this. So all you got to really do is figure out how vSphere does it. How does vSphere connect machines? How does vSphere do quality of service? Well, Ronnie's kind of walked you through just about every bell and whistle in that system to show you how to do that. And if you want to, and you definitely should, jump over to VMware's website, get that trial account, play around with these technologies, because the more you have some hands-on with it, the more you're going to retain that knowledge. You're going to understand what's happening underneath the hood. Ronnie, thank you so much for joining us today and explaining these networking concepts using the VMware Systems vSphere. And looks like we've wrapped up yet another show. And we thank you guys for joining us today. Hopefully you've enjoyed this episode. We're going to go ahead and sign off for IT Pro TV. I've been your host, Daniel Lowry.
And I'm Ronnie Wong.
We'll see you next time.